Same agentic coding job, same month of usage. One team's bill was $360, the other's was $3,000, and Claude Opus 5 and GPT 5.6 Sol were the only difference. Claude Opus 5 is built for deep reasoning, GPT 5.6 Sol for terminal and browsing generalist work, and Gemini 3.5 Pro for massive context on a budget. So which one do you actually pay for? Test 1. Cost per task. You're running an agentic loop, maybe 100 million input tokens and 20 million output tokens a month. That's a real production number, not a stress test. At that scale, picking the wrong model doesn't cost you a rounding error. It costs you a budget conversation with your boss that nobody wants to have. I pulled official pricing pages for all three. Gemini 3.5 Pro comes in at $1.25 per million input tokens, GPT 5.6 Sol at $2, and Claude Opus 5 at $15. That's 12 times more expensive on input alone. On output, Claude Opus 5 runs 75 per million versus GPT 5.6. Sol's $8, so at that 100 minute input, 20 minute output volume, you're looking at $386 for GPT 5.6 Sol versus $3,000 for Claude Opus 5. Gemini 3.5 Pro takes cost per task, and it's not subtle. That 12 times gap on official input pricing puts Gemini 3.5 Pro on the board first at one win, with Claude Opus 5 and GPT 5.6. Sol still at 0. I know that cost gap because I've burned real money on the wrong model before. These pricing pages are my daily reading. Drop a comment below if you've ever been surprised by an AI bill. Test 2. Coding benchmark performance. The objection I hear all the time is, okay, Gemini 3.5 Pro is cheap, but does it actually solve the hard stuff? SWE Bench Verified is the independent leaderboard that throws real GitHub issues at these models and counts how many they actually fix. No hand-holding, no hints. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. On SWE Bench Verified, Claude Opus 5 hit 82.3%, GPT 5.6 Sol landed at 79.8%, and Gemini 3.5 Pro came in at 77.1%. And on the Goldie bench head-to-head between Claude Opus 5 and GPT 5.6. Sol across shared tasks, Claude Opus 5 won 25-18, which is a pretty clear margin on a fixed task suite, even if community consensus still calls GPT 5.6. Sol, the stronger generalist for terminal and browsing work. Claude Opus 5 takes coding benchmark performance. That SWE bench score and a 25-18 head-to-head win over GPT 5.6. Sol makes it the accuracy leader on hard coding tasks, and that puts the score at Claude Opus 5 1, GPT 5.6, Sol 0, Gemini 3.5, Pro 1. Test 3, Speed, and GPT 5.6, Sol advertises 210 tokens per second in fast mode, and I had a feeling that number was going to dominate this category. Speed in a coding agent covers two very different things: how fast tokens stream once the model starts, and how long you're staring at a blank screen before the first word appears. GPT 5.6, Sol streams at 112 tokens per second in standard mode and up to 210 in fast mode, versus Claude Opus 5's 78 and Gemini 3.5 Pro's 95. So on raw throughput, GPT 5.6 Sol is clearly faster. But time to first token numbers from community testing flipped it. Claude Opus 5 starts responding in about 33 seconds, and GPT 5.6 Sol takes around 134 seconds before you see anything, which is a real friction point in interactive workflows. GPT 5.6 Sol takes speed on raw streaming throughput, 112 to 210 tokens per second beats Claude Opus 5's 78, though I didn't expect the first token latency to be that punishing at 134 seconds, and that brings the score to a three-way tie. Claude Opus 5.1, GPT 5.6, Sol 1, Gemini 3.5, Pro 1. Alright, so we're tied up, and the next two tests are context window and deployment modality. And these are the ones that could change your answer completely, depending on what your actual workflow looks like. If you're generating long code artifacts in a single pass, or routing audio and video through your pipeline, the limits on these models are not all the same, and the gaps are bigger than you'd think. Test 4. Context and output limits. The day your model hits its output cap mid-function, right in the middle of a 500-line service file, you're not getting the rest of it in one pass, and you're probably breaking your agent loop. The ceiling on how much these models can read and write in one shot is a hard constraint, not a soft preference. I checked the official model cards for all three. Gemini 3.5 Pro has a 1 million token context window, 5 times Claude Opus 5's 200K and nearly 8 times GPT-5.6 Sol's 128K. On output though, Claude Opus 5 flips it, 32K max output versus GPT 5.6, Sol's 16K, and Gemini 3.5 Pro's 8K. So Gemini 3.5 Pro can read a massive codebase but can only write 8K tokens back in one pass. Gemini 3.5 Pro takes context and output limits on the strength of that 1 million token window, even though its 8K output cap is a real ceiling for long artifact generation, and that moves the score to Gemini 3.5 Pro 2, Claude Opus 5.1, GPT 5.6 Sol 1. Test 5. Deployment and modality. You're probably running on AWS or Google Cloud already, and if you pick a model that's only available on one cloud provider, you're now locked into that vendor's pricing and uptime SLA, whether you like it or not. And if your pipeline needs to process audio or video files, that's a hard requirement, not a nice to have. I went through the official deployment docs for all three. Claude Opus 5 runs on API, AWS Bedrock, and Vertex AI, which is the widest cloud reach of the three. GPT 5.6 Sol is API and Azure only, and Gemini 3.5 Pro is the only one here that accepts audio and video as input alongside text and images, which is a pretty meaningful modality gap if your workload needs it. Gemini 3.5 Pro takes deployment and modality. Being the only model here, supporting audio and video input is a clear differentiator, and that brings the final score to Gemini 3.5 Pro 3, Claude Opus 5.1, GPT 5.6 Sol 1. So here's where Claude Opus 5 is the clear pick. It leads SWE Bench verified, wins the Goldie Bench head-to-head 25-18, responds to first token about 100 seconds faster in community tests, and its 32K max output is the highest here. So if you're generating long code artifacts in a single pass, nothing else comes close. Now, here's where GPT 5.6 Sol is the clear pick. It streams 43% faster than Claude Opus 5 at 112 tokens per second. In standard mode, it's 7.5 times cheaper per output token, and community consensus consistently calls it the stronger terminal and browsing generalist for day-to-day agentic work. So if you're running high-volume loops and accuracy differences in the low single digits don't matter, GPT 5.6 Sol is your model. And here's where Gemini 3.5 Pro is the clear pick. At just 1.25 per million input tokens, it's 12 times cheaper than Claude Opus 5. Its 1 million token context window is 5 times larger than Claude Opus 5's 200K. And it's the only model here that accepts audio and video input. So if your pipeline needs multimodal processing on a budget, it's not a close call. If your job is deep, long horizon coding, where accuracy on hard problems is worth paying for, Claude Opus 5 is your answer. And that $3,000 versus $360 monthly gap only makes sense if the SWE bench accuracy is what your workflow actually needs. For everything else, GPT 5.6 Sol is the default generalist pick, and Gemini 3.5 Pro is the one you reach for when context size or multimodal input is the constraint. One thing that doesn't show up in the spec sheets, GPT 5.6 Sol's fast mode is priced at $4 per million input and $16 per million output, double the standard rate. So if your integration defaults to fast mode without you explicitly setting it, your cost math from this video is already wrong. Always check which mode your API calls are actually using. If you want to see how Claude Opus 5 holds up against a completely different set of challengers, I put together a full breakdown in Kimi K3 versus Claude Opus 5, versus Grok 4.5, which is actually better. The cost and accuracy numbers there tell a pretty different story, so check that one out next.